Hello everyone and welcome back. Today I'm going to be speaking about acceleration. Acceleration is simply defined as the rate change of velocity. Now, as you guys know, velocity is a vector quantity. So what does that make acceleration? Of course, it makes it into a vector quantity. The formula for acceleration, as you can see right here, is acceleration symbolized by A equals the change of velocity, delta V over t. So it's the change of velocity per time. Now, a little rearrangement, you can see that the change of velocity, it is going to be velocity final minus velocity initial. Always, when you have a change in something, it's always the final quantity minus the initial quantity, and of course we divide that by time. So let's talk about the units. What exactly are the units? Velocity is of course meters per second, as we saw in a previous lesson, and time is seconds. So it's meters per second per second. That makes it into meters per second squared. Not only are we going to see the formula for acceleration in this fashion, but also we're going to see it slightly different. So we can take this and we can rearrange it. And that is going to be your third formula in your reference table. So as you can see right here, okay, so we have acceleration, we said, is velocity final minus velocity initial divided by time. Now, if we divide this by 1 and we rearrange the terms to solve for velocity final, we can do that by simply cross multiplying. So 1 times velocity final minus velocity initial becomes velocity final minus velocity initial equals acceleration times time. So we cross multiply these two. And now, as we said, we're trying to solve for velocity final, so we bring velocity initial to the other side, so it becomes velocity initial plus acceleration times time. And we use this formula, as you can see right here, we use this formula in order to solve for velocity final, if of course velocity initial, acceleration, and time are given. As we just said, it is a vector quantity. So what does that mean? One of the concepts that you have to understand is this. If the object's motion is in the same direction as the acceleration, then the object is going to speed up. However, if the object's motion is opposite to acceleration, the object will slow down. This is depicted in the following diagram, as you can see right here. And let's look at the first one right over here. So, as you can see over here, velocity, so the motion of the object is pointing in the same direction as the acceleration, so the object is going to speed up. So it's going to go much, much faster. On the other hand, if the velocity, the motion of the object is in one direction and acceleration is in the opposite direction, the object is going to slow down. The best way to understand this is, of course, if we solve a couple of problems. So let's say we have the following problem. A particle is accelerated from rest to 50 meters per second in 5 seconds. Calculate the magnitude of the acceleration. So in this problem, they're asking us to find the acceleration. So we just saw that acceleration is, we said, velocity final minus velocity initial divided by time. So let's see. Let's check this out. It says from rest to 50 meters per second. So when the velocity is changing from something to something, that makes it initial quantity, and to something that makes it a final quantity. So, and from rest simply means that the velocity at that point, it is simply 0 meters per second. So what do we have here? So velocity final is going to be 50 meters per second. So we put it right here, minus from rest, that is 0 meters per second. We put it right here, and we divide this by time, which in this case is going to be 5 seconds. So as you can see, 50 minus 0 is going to be 50 divided by 5. That is going to give us a positive 10 meters per second acceleration. So that's the acceleration for this object. Now let's solve another problem. Let's say now we have a car and it says decelerates from 80 meters per second to 30 meters per second in 5 seconds. What is the acceleration? Again, we're going to use the same formula. So acceleration now is velocity final minus velocity initial divided by time. So again, from 2, that makes the 2 velocity, that makes it, of course, the final quantity, and from, that makes it, of course, the initial quantity. Initial. So, velocity final is going to be 30 meters per second minus initial, which is 80 meters per second, divided by the time, which in this case is going to be 5 seconds. So, as you can see right here, 30 minus 80, that is negative 50 meters per second now, divided by 5 seconds. So negative 50 divided by 5 now makes our acceleration negative 10 meters per second squared. I want you to notice one thing in conjunction with the previous problem. So in this case right here, acceleration was negative. So notice what happened. The car went from 80 meters per second to 30 meters per second, meaning it slowed down. And that's what deceleration is. Deceleration is simply negative acceleration. But in the previous problem, the particle, because there was a positive acceleration, it went from rest to 50 meters per second. So in other words, its velocity increased. So now let's see a third type of problem. What is the velocity final if this car starts from 10 meters per second and it accelerates at a rate of 3 meters per second squared for 11 seconds? Notice what they're asking us here. Over here, they're asking us for velocity final. So what exactly which formula should we use for this one? Well, we should use the modified acceleration formula that is already solved for velocity final. So that's going to make it velocity initial plus acceleration times time. So velocity final equals velocity initial, which in this case, it says that the problem says that it's 10 meters per second plus the acceleration, which is, it says it accelerates at a rate of 3 meters per second, so that is going to be positive 3 meters per second squared times the time, which in this case is going to be 11 seconds. So now, we're going to leave the 10 meters per second as is, and we're going to multiply these two terms. 3 times 11 is going to be 33. So 10 plus 33 gives us a velocity final of 43 meters per second. Thank you so much. Have a good one.